Hello, I'd like to welcome you to our last session today, the panel discussion that is going to conclude the first day here at ICNCE in the city of Aachen. We've heard great talks today about the different aspects of neuromorphic computing and engineering, about the technology itself, about the inspiration that can be drawn from nature, about materials, circuits, the architecture of those devices, about software and training algorithms. Well, the field of neuromorphic computing and engineering seems to be at an intersection of so many different academic disciplines: computer science, electrical engineering, neuroscience, physics, material science, and so on. So, creating artificial structures that are inspired by nature should always follow a multidisciplinary approach. But is this actually always the case in the field of neuromorphic computing and engineering? This conference might be a wonderful opportunity for a reality check. Breaking silos, crossing borders, making waves, interdisciplinary challenges and opportunities. That's the title of our discussion today. My name is Arndt Reuning. I'm a science journalist, and I'm going to host our panel discussion. And now I would like to introduce our expert guests. I'd like to welcome Giacomo Indivari. He's a full professor at the Department of Information Technology and Electrical Engineering at ETH Zurich and head of the Institute of Neuroinformatics at ETH and the University of Zurich. And I understand you're an electrical engineer by training. So what was your personal way into the field of neuromorphic computing?
Indeed, yes. I'm an electrical engineer by training. I was actually already, as a master's student, interested in biophysics. I took some classes from my professors on biophysics, and for my master's thesis, I studied the visual cortex and in engineering how detect textures and faults in textures with cortical models, which led me to study neural networks already in the late 80s, early 90s.
Okay.
Thanks to a postdoctoral fellowship, I managed to, so I was interested, so according to the literature, I found that there were really interesting research being done at Caltech with Pietro Perona and Christoph Koch. So I wrote to them, I said, I had my fellowship, can I come and work with you? And fortunately, they invited me there. That's where I learned about Carver-Mead and research activities in circuit designs and subthreshold circuit designs. But I was in the division of biology with Christoph Koch, surrounded by neuroscientists, theoretical, experimental, system neuroscientists. And from my fascination, I really learned as much as I could in those 3 years that I was there. Of course, going also to Carver land, so combining neuroscience, biology, and electrical engineering. And this is, I think, what shaped me. I got so much fascinated in those activities that even today I'm still working on those things. So very boring from that point of view, but this is how I got into the field.
Okay, thank you. Next on our panel is Panayota Poirassi. She's Director of Research at the Institute of Molecular Biology and Biotechnology at the Foundation for Research and Technology Hellas, fourth, in Heraklion on the Greek island of Crete. And she also serves as Secretary General-elect of the Federation of European Neuroscience Society, FENS. And earlier today you talked about dendrites, this connection between single nerve cells. Why are you so interested in these particular structures?
That's a good question. Well, I have a math background as a training, but I was always fascinated about the brain, how the brain solves problems, how it computes. So I went to the University of Southern California to study computational neuroscience with Bartlett Mell, who has been my advisor. And Bartlett was fascinated about dendrites. So that's how I got to know dendrites and appreciate their complexity and their computational power. So essentially, he was my first mentor and served as an inspiration for me to get into the particular field of dendrites.
I see. Thank you. And I'd like to introduce Max Zwelling, Research Chair in Machine Learning at the University of Amsterdam and co-founder of the startup company CASP AI. What is your main focus of research? Could you give me a brief overview?
The problem is I'm too interdisciplinary to pick one, really. So of course, machine learning is, development of algorithms is important, but the startup is about materials discovery using machine learning, so that's more chemistry. On my one day at the university, I really like to do neuroscience with great collaborators like Terry Sinowski and Lyle Muller. And yeah, so basically I do a little bit of everything which I really like, combinations of physics and chemistry and machine learning and neuroscience.
Thank you. And please meet Stanley Williams. He holds the Hewlett-Packard Enterprise Company Chair Professor at the Department of Electrical and Computer Engineering at Texas A&M University. Could you please give a short summary of your work on memristors?
Oh, well, I stumbled across memristors probably in around 2006 when I happened to read a paper from Leon Chua. And, I looked at this IV curve that he was drawing, and I said, well, I don't know what we are actually making in my lab, but it sort of looks like this, and this is what I want. And so I spent a couple of years just looking very carefully at it and asking myself, is this a mathematical entity, or does it have any sort of physical reality associated with it? And so I would say that my contribution to the field was just to show that one could build physical instantiations of memristors and other related devices, that they were real physical entities with important material properties.
Thank you for your initial statements. So here we are, 4 different experts covering a diverse scientific background, all of them kind of working on neuromorphic computing and engineering, each from a slightly different angle. And I think everybody should be familiar with interdisciplinarity, all of you especially. And frankly, I think everybody will agree that this is a worthwhile goal. But on the other hand, an interdisciplinary approach means a lot of extra work. Wouldn't you agree? So, since you have to familiarize yourself with the basic principles of another subject, sometimes even just with the technical language, the technical terms. So sometimes I'm under the impression that to a certain degree, an initial approval of interdisciplinarity turns out just to paying lip service. What is your experience? Could you give a brief account of your own experience with interdisciplinarity and also mention the difficulties you have encountered? Please.
Yes, I can start. I have encountered difficulties indeed. In general, I would say there are 2 types of researchers. There's the specialists and the generalists, and the interdisciplinary is more on the generalist side. And I think you need both. Specialists are the ones that are really the world experts on some very specific topics. So in circuit design, for example, the best A to D circuits, the best amplifiers, the lowest power circuits that do something. Whereas in the generalist case, the interdisciplinary, we need to be able to connect the dots. If we see some circuits and we see some functions and we see some structures in biology, there are advantages and disadvantages. The generalists usually are not considered with high opinion by the specialists in any of those specific fields. However, the advantage is really that the specialists do not have the time to be able to research the literature and connect the dots. So these are the 2 things that I think advantages and disadvantages of the 2. And so I am not as versed in circuit design as the specialists, or in neuroscience as the neuroscientists. So I see those as my disadvantages.
I see. Anyone else would like to chime in?
Yeah, so my experience is that if you have multidisciplinarity skills, you can readily adjust to your environment. And let me give you an example. Myself, I had a math training, right, but I wanted to be a neuroscientist. So doing computational neuroscience was, let's say, a way to use the math skills to get into neuroscience, which was an excellent experience for me and gave me the opportunity to see how I could apply my math training into understanding the principles with which the brain works. But then when I returned to Greece after my PhD, I was unable to find a job as a computational neuroscientist, and then I put my math skills into work again and worked in bioinformatics, so in a very different field. And that was very useful because I could get a job, but also very interesting because you can see how different skills that you learn when you work in a multidisciplinary environment can be applied to other disciplines. And the last 4 years, I've even been doing experiments in my lab, which is another, let's say, field of research. And again, there, you can apply the same principles that started out in math to design the experiments so that we will be performing in the lab. And I find it extremely useful that by having such an interdisciplinary training, one can adjust to the very different aspects of research. So it improves your, let's say, generalization abilities, as Giacomo just said, because you can connect the dots. But also it can open up a lot of different doors for one to become expert, if they want, into many different subfields. So I think that's super useful.
Mm-hmm. Max, any major hurdles on the way to interdisciplinarity?
Yeah, I think there are hurdles, although for somebody in AI these days, it's very easy to become interdisciplinary because everybody and their mother want to use AI in whatever they are doing. So you're sort of sucked into it quite easily. But to do it right is not so easy, actually, because first of all, I think you need to have a deep interest in that field. Otherwise, you will just not have the patience to get through years of, working with someone. Mm-hmm. And you have to have humility and respect for the other side, for the domain expert. Machine learning people sometimes tend to be a little bit arrogant in the sense, give me data, give me compute, and I'll solve this problem for you, right? Get out of my way. Now, that's, you really have to be, that's not how it works. It's really important to realize that's not how it works, right? So it's really a balanced game. You have to really think very hard and listen carefully to the domain expert. And so basically this is what I'm doing now for my, in my new startup. I have 4 days a week. When we hire the team, half of it, no, actually not. It's like 1/4 is it machine learning, 1/4 are chemists, 1/4 are engineers, and 1/4 are business-like people, right? And so you really need all of these people to work together in order to make this work.
I see. Stanley, any thoughts?
Oh, yes. When I was at Hewlett-Packard, I had a very large multidisciplinary laboratory. And my chief job was to act as an interpreter because all of these different disciplines in my lab, the people were all very smart, and they figured that they were actually smarter than anybody else. And they all had their own sets of terminology. The one that just drove people crazy was defect, because the word defect means entirely different things to people in different disciplines. And so we used to have knockdown, drag-out brawls over literally the definition of a word. And so a large part of what I had to do was, first of all, convince people in one discipline that the people in the other disciplines were actually very smart and they knew what they were doing. But I had to teach them how to listen carefully and not make assumptions about a particular word that they heard. And we literally had to define our own vocabulary. And so we did. And in fact, that was both good and bad because we got so comfortable in our own vocabulary, people would go out to conferences and we would talk our vocabulary and nobody in the audience had any idea of what we were talking about. So it's this issue that all of these different disciplines have their own ways of describing things. They will use the same word for completely different things, or they will have a very common thing that they've got, but they use different ways of describing it. And trying to get through that was the biggest problem of trying to manage this group. But eventually it worked. But as I said, we wound up developing our own internal language that was not understandable by anybody else because it was just ours.
So you needed some kind of a tool to translate the terminology. Well, how did you do it? What are tools?
I was in an industrial research laboratory, and so I could just say, this is what it's going to be. All right, so this is not an academic type of exercise where you have to herd cats. I essentially would take some input, but then I would essentially say, okay, from now on, we use this word, this is what we're going to mean by this word. And so I did some, I'll call it management from top down. In order to do that, because if we had tried to allow things, I'll say, to evolve naturally, it would have taken forever, and it just would have been just continual fighting, really. So it was I made the choices, and I'll admit that not all of them were great, but people adapted, and once we got through this language problem, which took several years. We actually made very good progress.
I see. What might the tools be to promote interdisciplinarity in your research groups? Giacomo.
Well, one of those is really interactions in order to come to a common language. So in our institute is very interdisciplinary by nature. There are mathematicians, biologists, psychologists, engineers, physicists, and we have weekly meetings, many weekly meetings, because it's important that the various domain experts really learn to speak the same language, or at least understand the others. And so I think having these meetings is really important. It does take effort, it does take time. I remember one of my students, a hardcore electrical engineer, was refusing to go to these meetings. He would say, yeah, I couldn't care less about, GABA A neurotransmitters, but it's just a waste of time, why should I go? And again, I had some top-down management saying, you have to go. But years after that, he thanked me. He sent me an email saying, I really have to thank you for forcing me to become interdisciplinary, because I could land a job in Apple thanks to my extra skills in addition to the electrical engineering skills. But I think communication is one of the most important instruments to promote interdisciplinarity.
By joint colloquia, by workshops, what do you think is the role of such a conference like the ICNCE here at Aachen?
The role of the conference? What do you mean by that?
Well, here, if you're in your own group, at your own institute, you meet people from your own area. I think this is kind of a meeting point for all the different academic disciplines from different countries. Is this important for you to have that exchange across borders?
Absolutely. And already gotten a few business cards from today's presentation, so that's great and that's exciting. I think it's really good to come into these meetings that are a little bit far from your own discipline, at least that's how I feel, because you get to meet people that are doing things that you would otherwise not even know about, right? And have the opportunity to see from a different angle where would the research that I am doing, let's say, could have an impact as part of an application? Because for me, doing basic science, for example, in my lab, I would not readily think of developing a device or developing a machine learning system that would be used in the industry, for example. But being in a meeting like this and seeing how other people go about doing this and what they could find interesting in my research, that is both satisfactory and also opens many doors for new collaborations. So I think this is a great meeting and should continue.
So I see we've found, or we identified certain tools like joint colloquia, conferences, maybe a jointly supervised doctoral student, and so on. But shouldn't we put more emphasis on the research opportunities that arise from multidisciplinary work? Just to raise awareness that collaboration between disciplines could lead to great benefits in terms of, papers and things.
Yes, I take.
Yeah.
So I think maybe one thing to address is that there's also a bit of friction for people who want to go interdisciplinary because there are artificial boundaries in academia.
Yeah.
And sometimes if you're not like an expert in one area, so if you're not an expert in one department and you're not an expert in the other department, you're not being taken seriously by both, right? And so taking away that friction somehow to make it, to reward people who do work on that boundary, I think is one important thing we should really.
But how would you do it?
Joint authorship.
Yeah, go ahead, yeah.
So, I mean, a really good thing, we have this often in my lab when we collaborate with experimentalists and we do the models for them, right? Who would be the first author, right? And I always insist that if it's a joint project and we have pretty much equal contribution, that both the first author and the last author are acknowledged as joint contributors, because this is a very important incentive for the person that would do the job to actually devote the time, but also a recognition that they can use later on in their CVs to apply for a new position or to apply for a new grant. So I think one very simple way when you have interdisciplinary papers is to give credit to both two or more teams that have done complementary things in an equal manner. That's one idea.
I see. What is the best way to share knowledge between different disciplines to equalize the knowledge levels?
Well, I think that, the first issue is just respecting people.
Yeah.
Just realizing that this, you're talking to a person who's every bit as good as you are in a different field, and if it sounds weird or if it sounds stupid, that's your problem, not the other person's problem. So you have to you have to learn how to listen. That's probably a thing that scientists and engineers don't do very well. We're very good at standing and delivering, but we're not very good at listening. And so this conference is a great opportunity for people to go and listen to people in other areas give a talk and see what's important to them, see what's interesting to them, and realize that you're not going to understand it in detail because there's all of this background that you don't have. But you don't despair, and you do not essentially say, well, this is not important to me, or it's not important to the field because I don't understand it. That's the one thing that just drives me crazy. Is when I run across people like that, and so it's this issue of learning. I've had young people come up to me many times asking me, what's the most important class that I can take as an undergraduate in order to be able to work in a multidisciplinary? And what I tell them is journalism.
Journalism?
Take a journalism course. You have to learn how to listen in a journalism course.
That's a great idea.
So maybe I have a suggestion for this conference, which is, in order to lower this barrier that you're listening to something, they have half of the terms you have no idea what they're talking about, is to start every day with a tutorial. Actually, the tutorials in these big conferences like NeurIPS and the machine learning conferences are oftentimes the most interesting part because you get to learn something about some other adjacent field. So if you just start the day with a tutorial that's really accessible for new people in the field, and I think it'll become very popular because people learn the terms and what's important.
But aside from this, do you use any, let's say, IT platforms to share knowledge or to do tutorials? Are there any maybe videos that you put on YouTube or whatever? Giacomo, perhaps?
Well, we try to use all the tools we can get our hands on, so from Jupyter notebooks to GitLab repositories and things. But I think the one of the most important tools is to promote discussion through summer schools or tutorials. So maybe not just a 1 or 2 day conference where people come with slides, but really like a 1 week or 2 or even 3 weeks events where students get to see the tutorials, to work on hacking sessions, to work on robotics or different types of projects together. So The university courses and master's programs are starting to become interdisciplinary. There is more and more. But for sort of state-of-the-art, very advanced fields that move very quickly, these 2 or 3 week workshops probably are also going to be very helpful in spreading the knowledge, creating a community, and then allowing students and researchers to share their output and their tools with everyone.
Does any one of you use social media to connect or just to spread your own research and to connect to other researchers? Max, you're...
Yeah, I'm on Twitter X, whatever we call it, and you know, when actually in our field it's quite common now that if you write a paper, you actually have a whole long Twitter feed on that particular paper with lots of beautiful visualizations and GIFs and whatever. And I'm always asked to, you know, to redistribute that for my students with a nice sentence like how important and fun this paper is. And this is a very important channel for us, actually.
I do the same, yes, also on X Twitter, and writing threads for different papers or conferences when I organize something. I think a lot of the input about articles of interest or events nowadays, especially to young people, come from Twitter. Because it seems to be the favorite, let's say, social media for scientific content, or at least it used to be when it was Twitter. Now I don't know what happened with X. Things have changed a bit. But yeah, social media is important.
But do you feel you can benefit from it?
I find a lot of interesting papers from it, yes. So yeah, I think it's quite useful.
Well, another question I'd like to ask is, what is the best time during your academic career to start working across different disciplines? At the beginning of your university studies as an undergraduate student, you're usually far too busy with your own discipline, unless you want to go for a double degree straight away. Some postgraduates consider looking at another discipline during their PhD. Let's say as an electrical engineer or physicist, you might try to get an additional degree in economics or in computer science. What is your recommendation based on your own experience, Giacomo?
Well, as I said, there are starting to be around the world interdisciplinary master's programs that try to combine different disciplines. But as I agree I would say that during your master's studies, it's important to get a solid base in physics or math or at least combining some, but not many disciplines. I think, at least personally, the best time where I could really explore interdisciplinary concepts and learn about new things was my postdoc years. I think that's the time that I enjoyed most, learning and going to conferences, going to summer schools.
Yeah, I'm not sure there is an ideal time. Like for me, I've been doing a different thing for an undergrad, then a PhD, and then a postdoc, and now. So I keep changing, and I really like it. So I think it depends a lot on the personality as well as the opportunities given. Maybe if someone starts at the master's level, it's probably good because then it gives you more openings for a PhD or a postdoc. On the other hand, I also understand the need for someone to get a job first and then, feel secure and then start exploring other probabilities. So I think it's a lot of a personal choice kind of thing, and it would work at any stage, in my opinion.
Mm-hmm. Max, your
Yes, I think I agree with what was said in the sense that there are certain things which are just harder to get into when you're older than other things. So for instance, there's very few people who've never seen quantum mechanics and then when they're 30 start to do quantum mechanics, or hard math. So just get the hard math stuff out of the way when you're young. You have the time to do the exercises and all that. And then later add something to it, maybe a sort of a certain domain. I'm not saying that's an easy job, but I would say, very hard math is just very hard to do at a later age.
Yeah, sure. Stanley?
Well, as a hiring and firing manager for many years, I learned over time that when I hired somebody, I needed to hire somebody who had gotten very deep. I needed people who knew how to go into a problem and just attack it and get as deep as possible in that one problem. then, you know, my own view was that I would help that person become a pie type of person, or, you know, start to add other types of experiences to encourage them to broaden out. But my own experience was that if you hire someone who comes in with one of these, I'll call them breadth types of educational backgrounds, they were totally useless. They were absolutely unable to solve any problems because they'd never gotten deep in anything. And it was not, it just, you know, they just didn't know how to do it. And so at one point in time I thought, well, that's kind of cool. I mean, having all these different types of experiences, but no. You know, get deep in one thing, become a real expert in that one thing, and then you can start broadening out as you move into your research career.
Yeah, thanks. What do you feel? What are the limits of interdisciplinarity? Do you feel there is a danger of getting bogged down by doing too much of interdisciplinary work? Is it a burden, Giacomo?
Again, I think it's it's more related to the character and the personality than the idea of interdisciplinarity. The risk is that there are so many exciting things that one just never stops looking and trying to learn. So there are risks, but again, I think it depends on the personality.
I think there's a risk of spreading too thin. So if you like a lot of things and want to get involved in many different aspects, I mean, as a group leader, right, if you do your own interdisciplinary research in your lab, there is a risk of becoming slowly less of an expert in each one of the things that you used to do independently. And this can be negative for funding, for example, or even for supervising people. So there is that risk. But the way to avoid that is by not trying to do everything yourself, but instead collaborating with other people that do the interdisciplinary aspect that you cannot do. So there is a balance there that one has to decide for themselves as to at which point they can handle this interdisciplinarity and where they should stop and find a collaborator.
So it's an individual decision.
I think there's risk, certainly for young people there is a risk, because let's say you're in machine learning where we run from one deadline to the next one. You're sort of expected to publish a few papers in one of these big conferences a year. Now, if you get into a collaboration with a biologist and the rats get a disease and the whole new strain of rats needs to be grown and you're waiting for 2 years, right? So that's just slower. And maybe people in that science understand that can happen. But then to you in your discipline, people might not really understand it. So that's a certain risk that you take if you're young. If you're older and you're settled and you have enough papers and H indexes and whatever, then that's less of a risk, I would say.
Thanks. Sammy?
Well, I think that, my approach has been evolving toward what I'll call an appropriate teaching approach. And that is, you asked about social media earlier, but I'm not a big fan of social media. I'm not on anything, and I never will. I already get bombarded by way too much, junk email. So I just don't need any more. But what I do is I go out and I find really good lectures, really good, presentations on the web, and in teaching classes, what I will do is I will assign the students to watch a master give a presentation on a particular area, and then we'll have an inverse class. The class is all about discussion. What did you see? What was interesting? What worked? What didn't? What did you learn? And so rather than trying to do the, as I said, stand and deliver type of approach, it's take advantage of what's out there, because there's a huge amount, and there are some absolutely fabulous people who give fantastic lectures, far better than anything that I could ever do in any particular area. So utilize those, expose people to them, expose people to these experts, and then have a discussion. That's the sort of the inverse lecture type of approach, and I found that it's worked very well.
So this conference is, amongst others, supported by the Cluster for Future Neurosys. Its aim is to develop neuromorphic systems that are suitable for AI applications, particular. And that cluster also follows a multidisciplinary approach, and this includes ethics and economics. How do you feel about this? Are these two subjects that are usually overlooked when we're talking about your work? Ethics and economics.
I think they might have been overlooked in the past, but actually more recently there's much concern about the type of research that we do, and funding agencies are actually asking us to take that into consideration, write ethical reports, even if we're working on, at least from my side, very basic research that's at least 10 years away from anything that could go out in the real world. But in my experience, it is not being overlooked anymore. In the last 3-5 years at least, it's been more and more often that universities, funding agencies, governments are asking us to really look into the ethical aspects of what we do.
Yeah, I have the same impression, especially for our research with animals. This has traditionally been an important subject for ethics, and there we have been having to submit reports and do experimental design. More recently, there is a lot of discussion about the ethics of AI, so now we have to start filling out forms for that as well. About economics, in my experience at least, this has indeed been overlooked. So we don't normally discuss any economical impact, if you like, of our research, but also we are doing basic science. So maybe for industries, this is very different.
Yeah, I think you're closer to the AI field.
Yeah, so first maybe about ethics. So ethics is in itself an interdisciplinary thing. So, you know, I'm not an ethicist or whatever, philosopher, and I shouldn't pretend to be one. And so if you want to think about ethics, I think you need to do it with the experts in the room. And of course, we have a responsibility to explain what our technology can do, because other people just simply don't understand how powerful it can be. So it's our job to explain it to politicians and ethicists to say, okay, you know, this is what this technology can do, and then have a conversation about, you know, what are the dangers and what can be done about it. In terms of economics, I think there's also a risk focusing too much on it, because we need to be able to do free research. In some sense, industry and startups are about, you know, monetizing or commercializing inventions and bringing them to society, hopefully for good, for good, you know, to bring good. But as a pure scientist, I wonder if we should focus on it too much, because it might make you myopic. You might just start to think about things which can make money now, where, as opposed to thinking about something that's completely crazy and can, you know, you can't imagine any way in which this can make money, but, you know, potentially in the end it will.
Sure.
So anyway, but industry and startups definitely take care of that. So if you're interested in that, you know, start a startup or join big tech, and you'll definitely be confronted with, you know, with the economic side of things.
Mm-hmm. What's your experience?
So I have a center funded by the Department of Energy at Texas A&M. And as part of the center, we are required to provide our students and postdocs with lectures and material that discuss ethics in research and in the applications of technologies. And so that is a required part of our program. And that's more and more common, at least in the US, for various funding agencies. Since I'm in an electrical engineering department, the department itself has modules in essentially, you know, beginning electrical engineering courses, which are intended to teach people about pathways to commercialization. And then there is actually a full-blown course on you know, startups, as well as a wide range of opportunities for students to work in startups and experience you know, what that's like. I mean, for a long time, of course, people, you know, would do internships at national labs or large companies. Well, now we're looking at the opportunities for people literally doing internships in a startup environment, so that they get that feel, they understand what that is. So it's I think that both the ethical and in an engineering environment, the economic issues are very important. You can't cram absolutely everything into people, but those are two things that I think are essential, and they have my essentially my full backing in what we do.
Thanks so far. And now we've got some minutes left. I'd like to open up the discussion. Are there any questions from the audience? Professor Vasa.
Yeah, thanks a lot so far. Colleagues, I heard a lot of interesting and nice things, but what I did not hear is the role of pleasure, of excitement in the discipline which you are working in. I mean, perhaps it's understood, but I guess it should be expressed as well. So whatever discipline you are working in, you should be excited about, you should have pleasure in looking into this field, and you should also have a possibility to overcome frustration, because sometimes the pleasure goes down, frustration goes up, and you need a tool to overcome this. How about this?
Maybe I can start. Thank you, Reinhard. Indeed, I was giving it for granted, so I wouldn't be here if I didn't like to do what I'm doing. So already from the master's program and the postdoc, I really took pleasure in studying these things and working on them. So I feel privileged because I'm paid to play and to have fun. And indeed, it's maybe even is too much, because I end up doing these things also, until 2 in the night or over the weekends, and so it's difficult to try to force oneself not to only do that and to also balance life and work. But it's true that if someone is looking to pursue an academic career, this pleasure is a necessary condition, because the academic career really takes a lot of time, and if you don't like to do what you're doing, then it's going to be very, very painful, or not very successful. So I think pleasure is really an important ingredient. And then as an educator, our role is to try to pass this passion on to our students, to show them how fun it can be to actually work on these things.
Any other thoughts on motivation? And
Should we take another question?
there's another question.
Yeah, I wanted to say, I'm Florian from RWTH, and I wanted to say if it's better to do academics or to join a startup to get into this interdisciplinary expertise.
Maybe I can start? Yeah. I think it depends a lot on what you like the most. So in academia, there is a freedom to operate, as Giacomo just said. So if you have a passion for new discoveries, then academia is for you. But it doesn't pay that well, as well as industry, let's say. So if financial future is another concern, maybe industry is a better option. I think it's a very personal decision. Of course, nowadays there are a lot of industries that also have a lot of freedom in doing research, especially big companies. I don't know about startups. So it depends a lot on how one sees their own future. Curiosity-driven, or more like producing an important product or output that would have a major impact on the society. That's my own thinking. But maybe.
So I think that, of course, it depends entirely on what drives you. But I will observe one thing. I know a lot of professors who have started up companies. I don't know anyone in a startup company who's ever become a professor. So there is a diode issue involved. That said, it's the pleasure factor, right? It's what gets you up in the morning, and what and what makes you look forward to facing all of the crap that you're going to face during the day, because there's going to be a lot of that, and you need a lot of positive reinforcement to get through that part of it.
Yeah, thanks. And we've got another question over there.
Yeah, hi. Thank you for this very interesting panel discussion. My name is Timo Jierlich from University of Bern. And I'm wondering about your opinion on diversity and equal opportunities and integration in research, and what are your ideas to maybe improve upon this? Thanks.
Who would like to answer this?
Maybe I can give a quick. So I think at this point, women have better chances than men. I have a daughter, and it's great that the market has turned around. I've seen it in industry. Of course, it's been reversed many years. So now I think women have better chances in the tech industry, at least. And that's because there is too few of them, right? So their market value goes up. So one thing we really need to do is to encourage more women to go through, tech education, so that that situation gets more balanced. So this, I think, is the current situation, and yeah, I think it's good. I think this is how it should be in some sense. The sort of the better opportunities for women on the market.
I can maybe follow up on that. I'm not so sure. Maybe it looks like that, but at least the data from the University of Zurich, there are more female students at the graduate level and undergraduate level than postdocs or professors. So it's still something that requires attention to increase diversity. And there is a lot of attention. I think I can speak for the University of Zurich because that's where I know the data from, but I have the impression that many other universities are actually paying more attention to this issue of diversity. Of course, I think it can only make a group richer, and it can only provide benefits for research, for the research environment. I was very fortunate to have a diverse group in my own lab at all levels, from the senior researchers down all the way to the students. But in other groups, I see that it's not exactly the same. And I say I was fortunate because, as you say, it's very hard to find talented female researchers at the level of postdocs because of this leaky pipeline problem. So it is something that needs to be taken into consideration and addressed. There is improvements in the last 10 years, but I think there's still a long way to go. So that's my experience.
Yeah, I would fully agree, and I think it depends a lot on the country. Like in Greece, for example, the problem is much bigger than in other European countries, not only for women, but for other diverse groups as well. And it is really important that we pay attention to it and strive ourselves as PIs to form a diverse group and help people have equal opportunities. And it's hard, the more theoretical the discipline, like ours, it's harder to find female postdocs that would like to apply. So you need to give some extra incentives in this case, maybe some support for childcare, maybe, I don't know, some extra salary or something, to help people make the decision, because it's not solved yet, at least not in academia.
I wasn't saying it was solved, but I just say that in industry, in big tech industry, they can demand higher salaries at this point.
Glad to hear it.
So, any other questions? Yes, over there.
Hi, Shankar from IMEC. So I have a question regarding the patent filing or IP filing. So you already mentioned about the publications. So kindly preferred having joint collaboration in publications, the contributions. But what about IP or patent filing? Because that comes from more like a specific contribution of a field, right?
Well, my own experience, and I was actually in charge of IP issues at Hewlett-Packard for quite some time, is that in large companies anyway, the drive to patent is going down. That larger companies are de-emphasizing patenting and looking at things being more secret, being their they're crown jewels in some sense. That's a little bit different for startups. In many cases, a startup needs to have a patent portfolio in order to be taken seriously by venture capitalists who want to invest in it. They want to see that the people have been serious about all of this. But there's one thing that you've just got to understand about patents. Patents are a sword, not a shield. And so if you've got a sword, but you're some little tiny guy and you're going to go up against some great big huge behemoth company, they can just kick you out, and you have no resources to be able to deal with that. And in part, that's one of the issues why patenting is actually getting less and less attention. It's the cost of actually defending a patent is just exorbitant, and very few places can actually afford it.
Actually, I have another follow-up question on this one. So do you think that this huge amount of paperwork that one need to do to first start a collaboration is actually hindering the actual, the cause of collaborating, like a scientific collaboration?
I think if there is interest in collaborating, we will find ways to collaborate, even by using our own budget or making our own efforts. So the huge investment in paperwork is for finding financial support for new students. But again, if there is passion, we will put in our time to try to find ways to get a grant approved, even if it takes 3, 4, 5 iterations. But the passion will start the collaboration during the conference, at the conference. We will start irrespective of the finances, and hopefully those will follow if something comes out of this. This, again, is my personal experience.
Yeah, I fully agree. Most of my collaborations started without funding for it, and it comes on later. Yeah. So that's not a major problem.
Thank you.
Okay, no further questions? Then I would like to thank our panelists again. And thank you all here at ICNCE, and have a pleasant evening. Bye.